And Patrick Van Cotter will talk about their experience with DANE. So, please.
So, hello. This is Carsten. My name is Patrick. We're here to talk about DANE. We've been implementing DANE technology throughout last year. Probably one of the key sentences in memory is that DANE secures security. You might ask yourself, why would you want to secure security? If you want to answer that, you have to take a look at typical encryption models. I'll be talking about SMTP first and DANE, what it can do for that, and we can go to different aspects later. Something everybody wants when they do encrypt is they want mandatory encryption. That is, you want it, you want reporting if something fails, you want all the alarms and the bells and whistles. But everybody, or at least most people out there, seem to be doing only opportunistic encryption. And opportunistic encryption does not ring any bells or come with alarms or things like that if things go wrong. So what could possibly go wrong? First of all, encryption means you need to use certificates. Certificates means you have to use certificate authorities, and there have been some problems. The major problems are here on this slide. I go for them right now. So, first of all, part of the problem with the certificate authorities is that any certification authority can issue a certificate for any domain, and they don't seem to be cross-checking. Also, the one or the other certification authority has been broken in a few years ago. As you probably might remember, the DigiNotar, especially here in the Netherlands. So there's a problem with the certificates that you go and buy from. Another problem you have is there is session downgrade, which means SMTP, as it is today, has no way of signaling beforehand that the target server you're connecting to is able to encrypt the connection. So you only find out at the moment you talk to that server that the server would or might be able to offer TLS, that is encryption. Somebody else might intercept the connection and just might take the TLS away. Are others doing that? Yes, they are doing this. It's happening today. The Electronic Frontier Foundation has written about that some ISP do that, and others, vendors of hardware too, in order to enhance security or in order to enhance their products, which is probably not something you want if you are eager to use transport layer security. And then there's man-in-the-middle attacks. That is, if somebody built their own certificate with the same hostname you want to connect to, or if they go and, for example, breach DigiNotar, as it happened, and create their own certificates for a well-known domain, they might intercept that connection and they might present themselves with a perfectly valid certificate, which is even worse with TLS in an SMTP world, because most servers out there will happily accept self-signed certificates. So you might turn up with the name example.com while you really want to connect a totally different server, and you're delivering the secret message to somebody else. And one of the reasons many people don't use mandatory transport layer security is it's very hard to automate it. If you really want to take security really seriously, you probably connect to that destination you want to encrypt to. You look for the fingerprint, and you pick up the phone and start talking to somebody on the other side. Try to get the postmaster and talk to them and verify the fingerprint, so you really know whom your server is talking to. This turns out to be hard, and it turns out to be a real problem because you are not in control of the other side. If the receiving server switches certificates and you have a hard-pinned certificate on your side and you say, only talk to that server, if that server really comes up with that fingerprint and they change the fingerprint, then you have the problem. And the thing is, they have no idea that you have mandatory encryption on your side. So they change the certificate and messages start queuing up on your side because they don't know how to notify you. How could one secure that? Well, the plan is to add a policy channel in which you can signal a few things. For example, you could indicate that the destination supports encryption. You could also indicate that the identity of the destination your server should connect to. And to have that transmitted in a secure way, you would add a trust layer. And this is where DANE comes in. DANE is the shorthand for DNS-based authentication of named entities. It uses and requires DNSSEC. DNS becomes a policy channel, whereas DNSSEC adds a trust layer. And now that you have that framework to transmit policies or transmit information, you start connecting systems. You start to tell machines that are interested what they want to know, and for that you start using new resource records. I'll go over the resource records in a minute. The current use cases that we have there is you could use DANE to enhance HTTPS connections, SMTP, OpenPGP, and SMIME. We'll be going through that bit by bit now. In HTTPS, you would publish a TLSA resource record indicating that there's a resource on port 443 TCP on www.software.de, and you would tell that resource that is in a TLSA resource record saying this is a public certificate bought, that's the certificate usage. Then you would say use that selector. Selector says either pick the fingerprint and a few information or pick the whole certificate to identify the certificate, and then the matching type, that would be what kind of algorithm was used to publish the information. If you do a query, this is what you get. And if you have the correct plugin, right now it's a plugin, you might find a signal telling you that there's a DNSSEC enabled server, that's the key, and that the server also has been identified through DANE. That is, the browser connects, the browser makes a lookup, finds out over DNS. I could identify that server over there by this fingerprint. This is something it gets beforehand over DNSSEC. This is something it uses when it connects to the server. The server announces it's able to encrypt the session. The server shows its certificate and its fingerprint. You compare the fingerprints, it's okay, they match, so I must be talking to the right instance. But this is userland, and userland has a few issues. We did a survey for an ISP in Germany, and we checked their cable modems for their DNS capabilities. And this is something that Carsten did. And we found out that all of them had more or less major issues when it comes to DNSSEC. So there's a lot of things, and there's still something we need to do. The reason why those products are not as DNSSEC enabled as we would like to have them is that they probably built them a few years ago and they've just been adding new feature, but they did not change the software in there. But this is something that's taking place, especially in Germany, where they try, where the government itself is talking to the ISPs and urges them to improve the cable modems out there for end users. It's a little different on the side of SMTP. SMTP, when I'm talking about SMTP, I'm talking machine-to-machine communications over wide area networks. Just to remind you what that resource record looks, this time you see it's support 25 on TCP to mail.cis3.de, which you probably know is a mail server the client should be talking to. There is a RFC which is right now in the working group's last call. It's been drafted and written by Wes Ardeke and Victor Duchovny. And the first implementation is to show up on the market where Postfix, OpenSMTPD, and Exim. Postfix especially because one of the RFC authors, Victor Duchovny, is also one of the two major authors of Postfix. So what you have right now, if you look at that RFC, you have a very well-written and also in practice proven RFC. Many things that he worked with while he implemented DANE capability in Postfix, many experiences he learned went back into the RFC. We at SIS4 have been using DANE and DNSSEC since the end of 2013. It's about Christmas time when you get time to do other things that only work in. And it's a small difference, but it makes all the difference. Usually you would have a trusted TLS connection when you connect to a certain destination. That means in this case, the client was able to look up the certificate and was able to verify the certification chain in its own certificate store. Verified TLS makes a difference. Verified TLS means I've been able to talk to find out that there is a DNSSEC-enabled domain. I was able to look up a TLSA resource record. I took the fingerprint from that via DNS, and I compared it to the server when I started to talk to the server, and they matched. So I know I'm really talking to the right instance. There's not too many domains out there right now supporting DANE, but the question is probably, does it have to be many domains, or does it have to be the one that makes a difference? For example, large ISPs, large providers, or certain probably governmental institutions. In Germany, it's Bund.de, which is the major portal for governmental information, and they are DNSSEC and DANE enabled. So this is, I think, a good sign to say that's that the important ones are adopting DNS and DANE. This is where Carsten takes over.
So the IETF, after working on HTTP and SMTP, is now also working on securing other protocols. And I will point out here PGP and SMIME and how that works. There is now a way, or it's being discussed, it's not an RFC, it's currently an internet draft, a way to store PGP keys in DNS secured by DANE. And the benefits here are that the keys are more in control by the actual user, especially the removal of keys is then possible, which is not possible in the classic key servers. Once you have it on the key servers, there's no way to get the keys out there anymore. With DNS, it's possible. You could just remove the resource record. And here's how that would work. This mail client wants to send encrypted email to someone else, and the mail client does a DNS lookup for an open PGP key. That comes back, is verified that it is DNSSEC secured, and that gets then the PGP public key into the mail client. Mail is being encrypted. Very similar for SMIME. There's the SMIME-A resource record that stores either the full certificate, the public certificate of a mail user, or a hash of that certificate. And here there's an example how a hash could be verified. Bob is sending an email to Alice, which is unencrypted, but contains the SMIME public certificate from Bob in an attachment. So Alice got this email and now is able to encrypt the response back to Bob. But Alice wants to be sure that it's really the right certificate. So the mail client of Alice will do a DNS lookup, asking for an SMIME record, getting the data back, which is either the full certificate or the hash of the certificate. Compare that with the certificate received from Bob, and if that matches, Alice can be sure that she is in possession of the correct certificate from Bob and can send encrypted emails. That can be automated. We at SysFor created a milter that can automatically do that. So it's not the mail client, it's not the user, the mail user that does this. It's in the mail server. Once a mail is being sent out to the mail server will look up the certificate and do automatic encryption. The same is also available for OpenPGP key, written by Paul Wouters, who is one of the authors of the OpenPGP key internet draft. There are next steps. The DANE working group is working on securing even more protocols. Work is done on storing raw certificates in DNS, secure that with DNSSEC, and on mutual authentication. For SMTP, for email, currently it's possible to authenticate the receiving server, but also the sending server should be identified so that both sides can be sure that they talk to the right endpoint on the other side. And there's a payment association record discussion currently in the IETF that would authenticate payment information, like account information found on some website, and link that to a domain and the owner of the domain. Back to Patrick.
Okay. Well, about who would benefit from DANE. Over the year, we've been talking to different people. What we found out is mostly what people think is who benefits about DANE is security service providers. That is any, of course, email providers or anyone who provides secure email. Those are specifically some of the companies we work in Germany. Also, email users with defined security requirements. When people start talking about security, they usually ask for the full scale, and they don't want to stop until everything is secure as possible. We'd rather talk about defined security, people who know how secure things need to be, and when you can stop dealing with more securing things more secure. Online payment, insurance, banks, enterprises, subcontractors. Sorry for the speed where we've been, have to go through the slides fast. Situation in Germany is right now, 55% of all .de domains are offer star TLS. There's 1% of them who's offering who offer DNSSEC. And this is a growth we've been experiencing over the last time. I've been have to talk to Peter to get a few newer figures. This is not as I said, it's not widespread in Germany, but as again, you have to figure out what are the importance domain you want to talk to. It's completely different here in the Netherlands because in the Netherlands, I've been told it's kind of sponsored if you go for a DNSSEC domain, so it's cheaper, so people start to use DNSSEC. So it's outnumbered by a big figure. What are the typical DANE roadblocks? Well, people they tell when they talk with registrars, they have their problems because they have problems finding one that supports DNSSEC. DNSSEC doesn't just DNSSEC doesn't seem to be the big market yet, so they don't offer it too loud. Also, what we get to hear is that people say, "Well, DNSSEC is a technology, but it's not a use case. What should we do with it?" DANE might be the one use case that people really go for because it helps them to secure the infrastructure and automate, which means they will start saving money when they do it more secure.
Yeah, that's what we see is that people don't implement DNSSEC because of DNSSEC, but they hear about DANE, they hear about the possibilities to secure the other protocols, so they want to have DANE, and then they recognize, oh, I have to do DNSSEC in order to do that, and then all of a sudden, implementing DNSSEC is not so much a question anymore because they want to reach the goal of having the additional security of DANE. So then there's money to implement DNSSEC, and that's what we have found.
Yeah. What we also find out is that, of course, you want to monitor it and apply good alarming to it because DNSSEC, well, DNS itself is mission critical, but if you get something wrong with DNSSEC, DNSSEC resolvers will not give information away, so you really are kind of away from the internet if you do something wrong with the DNSSEC. And missing tool chains for automatic management. That's something they're looking to also.
Yeah, if more and more data is in the DNS and DNS becomes more and more important, coordination is also important between all these certificates and PGP keys and MIME certificates being used and the data in DNS. So if now someone has DANE and the certificates being exchanged, care must be taken to also exchange the fingerprints in DNS, else everyone who does DANE validation will get a failure. And what's currently not existing in the market is proper management tools and monitoring tools, and we're working on that to make that happen both on the open source and commercial side. But yeah, we see first small tools appear that do that.
Yeah. Yeah, we talked about mission critical. This is a typical slide. We've produced a DANE Validator, and it's put it up at dane.sys4.de. feel free to use it to validate your DNSSEC status or to validate if you have DANE. What we typically find out is that many domains do have DNSSEC, but they miss that little but all-important step, for example, for SMTP, to add TLSA records. Once you have that, you're a fully compliant DANE website, or DANE domain, sorry.
Yeah, and if you already have DNSSEC, using DANE, that step is a very little step compared to the step of implementing DNSSEC. In
The hard part is DNSSEC.
It's just one resource record there.
Yeah. So to take away DNSSEC, you need DNSSEC as a one-time cost. What you get is you get an open standard with DANE. It makes your security management far easier because you can distribute all the policy beforehand. Machines can talk to each other and simply deal with that, and you don't have to deal with that. It even automates the rollover. The situation I've been talking about, that if the destination domain switches over their certificate and all mail starts queuing up on your side, you don't have that with DANE, because you simply bring in both certificates and the client says, well, I pick one of them as long as it verifies. And then you fade out the other one, the old one, and you're done. Thank you.
Do we have time for questions?
Oh yes, already queuing up there.
Warren Kamari, Google, and one of the co-chairs of DANE.
Oh, hi.
Hey, can you go back to the slide about the draft with Victor and Wes? About 7 or 8, maybe more back.
With Wes and Victor? Let me see, that's here.
That one. Just a quick update. Oliver and I called working group consensus on that on, I think, Wednesday, and it looks like we have consensus to proceed, so that should be moving along.
Cool.
Cool, thank you.
Hello, my name is Untitled Chapter from CESNET. I have a question and maybe then a comment. Since you deployed TLSA validation for your mail servers a long time ago, I would like to ask how many domains have you actually failed to deliver mail due to the problems with TLSA records?
My own. I exchanged certificate and I forgot to update the TLSA record, and it actually proved to work because the certificates would match and I wouldn't deliver from our company's domain to my private domain. This is something I found out. And besides that, we hardly have any interoperability problems, which might be contributed to the fact that DANE out there isn't that widespread yet.
Okay, so it's about the same with me. I actually observed four issues with delivering mails to such domains, and there were 2 of them were operational workflow issues connected with exchanging SHA-1 certificates to SHA-256. And usually the people that insert the TLSA records to DNS are different people than the people that are exchanging the certificates, and they are not communicating together. That's
one of the experience we also had, is you simply have to rewrite your worksheet if you work with DNS. You say, okay, there's something new, there's a new task I need to take care of. Check that. As for the DANE Validator, I just told you, we're working on a monitoring version of that. So somewhere between now and we have time to do that, we'll be offering a monitoring service where you will be able to register and have our side monitor your TLSA resource records, things like that, and they will alarm you. Yeah, and the rest 2 cases were actually connected to especially one DNSSEC hosting provider in Czech Republic that used some kind of esoteric software making DNSSEC, and these software have this bug that request for non-existent records actually cannot validate. So it's basically for most protocols so far it's no problem, because if you got NX domain or serve fail, nobody cares. The result for most application is just fail. But for the TLSA validation, it's a crucial difference, because if you got serve fail, you just suppose somebody is doing something with DNS and you just queue the mail and wait until it fixes. I believe believe that has been dealt with too. Victor Duchovny, that's how the DANE Validator project started, really was after those domains and that caused problems, and wrote to them and told them what they should fix. So we improved a lot.
Yeah, let's hope it will not expand to other providers.
Hopefully
because
not.
I know only about this one. Oh, thanks.
Thank you.
Thank you.
Chris Damien, Ripe NCC. Question from the chat. Lutz Donnerhacker asks, with DANE, the registry reseller chain becomes the weakest link in the certification. How can this chain be strengthened to support such values like TLS certificates?
We are not experts in securing the reseller registry model. We see the same problem. Yes, it's true that becomes the weakest link, and I think that is the RIPE community is a good place to discuss that. What can be done to strengthen that communication and that link between resellers, registries, registrars?
Probably not the right answer, or not the kind of answer Lutz would like to hear about, but in DANE you are able to roll your own certification authority and also indicate that in your TLSA policy. So you might be able to work around that. That is the way you would like to go for.
Thank you.
Yes, please.
Peter Hessler from Host Server. You mentioned that in general, home DNS resolver implementations often have problems with DNSSEC. Have you run into any issues with a DANE record as you're trying to send email or receive email?
Not that I'm aware of that there are that we have seen any DNS-related, DNSSEC-related issues when sending mail. Despite from the known DNSSEC issues that there are, like too large answer packages and IPv6 fragmentation, right, and whatnot can happen with DNSSEC, but that are just normal, I say normal DNSSEC, not TLSA DANE-related issues. Yeah.
Okay, thank you.
But nothing TLSA DANE specific.
Warren, do you want to follow up? Your body language seems to be halfway through between the desk and the mic. We have a couple of more minutes.
Okay. So Warren Kumari, DANE co-chair. I just want to follow up to the previous question. You're already trusting your registrar, registry, that entire chain, because if that gets hacked, somebody could redirect MX to a server they control, and then go to one of a whole bunch of certificate authorities and apply for a CA signed certificate, get the certificate, and then start using that. So, the registrar registry link is already something that you have to worry about. They already have sort of full control to make your life sad. Thank you, I was trying.
Peter Kordenik, I think that statement was probably a bit broad, but yeah, okay. Oh, sure. You better don't, knowing me. So no, seriously, the link isn't really becoming weaker, right? It's just that we have the strength put on what we used to sell DNSSEC with naming cache poisoning. Mm-hmm. What we've indeed done here is on a formal path making the DNS protocol more secure, so can we have the checkbox there? So that's the part of DNSSEC that gives you the use case. Actually, I was getting up for the other question regarding the home use and not having issues there. I think one of the important things and the interesting things about starting with MX records and SMTP is that actually you don't have to worry about the last mile in the first place, because usually the home user doesn't have their own SMTP system, so you act in kind of a closed club with hopefully people who are tech savvy and can operate a validator and signing engines decoupled from their customer infrastructure. So one important point is that there's a part where you can deploy DNSSEC without worrying to subject the customer base to all these rumored or existing difficulties with packet sizes and so on and so forth. You can do that kind of in a lab environment, except that's production.
Yeah, and same applies to the PGP, OpenPGP and SMIME stuff. Of course, that can be done in the client's mail client program, but maybe it's even better to move that to the mail servers, have these Milter programs do automatic opportunistic encryption, and then we can maybe bump up the level of encrypted email worldwide to a reasonable level without requiring all the email users to understand how keys works, how certificate works.
It simply works.
That's a hope.
Thank you, Carsten and Patrick.
Thank you.
And now we have a lightning talk from Sander Stefan about the latest developments in Saudi Arabia in regards to version 6.
Good morning.